Hello everyone. In this video, I will present my Module 5 Practice Hackathon solution using the telecom customer shown dataset with a focus on responsible AI, the fairness, the transparency, and the interpretability. So the goal is to predict whether the telecom customer will churn, and this is a binary classification task where the target is the run column. A churn prediction model can help the retention planning, but it can also impact how customers are treated. So it is important to evaluate the fairness and provide explanations. First, the data and the pre-processing. The dataset includes demographic information such as gender, senior citizen, service, and subscription information, such as internet and streaming service, and the account information such as term, contract type, and the charges. In pre-processing, I removed the identifies customer ID, converted the total charge converted the total charge to numerical, handled missing values with imputations, and one-hot encoded categorical features using the scaling and learning pipeline to ensure the consistent training and inference behavior. For the model training and performance validation, um, I trained the classic machine learning model using a random forest classifier right here. Um, For the validation, I use the cross-validation on the training set and then evaluate the final model on a holdout test. One test set, my model achieved that like, the random forest classifier here, and the result is here. The accuracy is 0.7715, the precision is 0.5522, the recall is 0.7353, the F1 score is 0.6307, the ROC AUC is about 0.8416. This shows the model is reasonably strong at identifying the churn, especially with the recall of around 0.75. Which can be useful for the retention using the case where the misinsurance is costly. Um, for the for the fairness and the evaluation, I evaluate using the gender as a sensitivity attribute and contribute the group metrics using the fair. Overall, the selection rate, meaning the rate of the predicting insurance, was 0.3534. And when the broken down by gender, the female selection rate is 0.3508. The male selection rate is 0.3560. For the fairness metrics, the demographic parity difference was 0.052, which is very small, indicating that the positive prediction rate is almost the same across genders. Equalize the odds differences was 0.0419, which suggests a modest difference in error behavior across groups, but not extreme. Overall, this indicates the model does not show the strong bias by gender in terms of who is predicted to churn. For the fairness mitigation attempt, even though the baseline fairness looks acceptable, I also test the mitigation method to follow the reasonable AI workflow. So I apply the fair is a threshold optimizer with equalized odds constraint, which change the decision threshold by group to try to reduce disparities in error rates. After the mitigation, the accuracy changed to 0.7864, and the F1 score became to 0.6116. The demographic parity difference become to 0.0157, and equalize the odds difference become to 0.0461. In this case, the post-processing step didn't improve the fairness metrics compared to the baseline and slightly reduced the F1 score. This suggests the original model was already relatively fair by gender, and applying the post-processing did not help. In a real deployment, I would likely keep the baseline model and instead continue monitoring the fairness over time. So for the explainability and the interpretability, to increase the transparency, I use a global explanatory with the shape. The shape summary plot shows which features most influence Schroen's prediction overall. In my results, the key drivers included the shape summary plot shows which the feature most influence Schroen prediction overall. And the key drivers include the senior citizen and the tenure. This is helpful because it provides stakeholders with a clear evidence-based understanding of the factors the models relies on. So, yeah. So I will complement this local explanation. For example, using the line of individual shape values to justify the specific customer value prediction when needed. So there are important ethic risks in the Schroen prediction. The potential demographic bias, such as difference error rates across gender or the age groups, and the transparency issue if the user cannot understand when a prediction is made, the privacy concerns become customer data must be protected. The the feedback loops where the intervention based on the prediction may reinforce patterns over time. To address this, I evaluate the fairness metrics, test the mitigation, and provided the interpretability using the shape to support the transparency and accountability. So the production, the readiness to make these models production ready, I would like to validate the input scans and the data quality at the inference time to monitor the performance drift and the fairness drift over time. The lock-in metrics like the AUC and fairness indicators, such as demographic priority and equalized odds. So keep model and pre-processing steps in a single pipeline to avoid the training serving school. So and use the champion challenges approach for the safe model updates. So in summary, I built assurance classification models with a stronger predictive performance and integrated a responsible AI workflow. So including the fairness evaluation, the mitigation testing, and global interpretability using SHAP, and this supports the ethic and transparent use of the Schroen prediction in the practice. And thank you for watching.